Did you know that your voice is considered personal information? It tells whether you're a child or an adult, where you come from and your gender. Your voice can even tell how tall you are and how much you weigh. People tell you apart from others by your voice. Sounds obvious, right? Well, it's not only humans and animals that can do that. Voice biometrics technologies, also known as speaker recognition, use AI to harness the personal information in your voice to identify you. So when do you think was the last time you used voice biometrics? Before you say never, think again.
You've probably encountered voice biometrics without even knowing it. It is widely used in call centers, where it allows agents to gain deep insights into customers in the hope of delivering a better service experience to you. Or maybe you have knowingly used voice biometrics that required you to set a passphrase. For instance, at Safaricom in Kenya, the words "My voice is my password" unlock your mobile wallet. At CIBC Bank in Canada, your voice grants access to your bank account. And at BBVA in Mexico, your voice serves as a proof of life that allows you to access your state pension. The promise of voice biometrics are convenience and digital security, but the stakes are high. Tiny and cheap microphones, embedded in almost every digital device, are creating a world in which hundreds of digital ears can listen continuously to what you say. Any microphone connected to the internet can be given speaker recognition capabilities. If left unregulated, this will open our intimate conversations to vendors and governments, trading our right to data protection for a bit of convenience. Powered with voice biometrics, microphones become tiny ears, in billions of devices, knitting an unobservable surveillance infrastructure.
There are two major applications of voice biometrics. On the one hand, speaker identification, like face recognition, can be used to identify you in a crowd. This means that it can also expose you to corporate and government surveillance. On the other hand, speaker authentication matches a voice recording to your voice to verify you. Authentication technology is used to secure your smartphone or smart speaker. While purposes of the two applications seem different, when it comes to the technology behind the systems, they are almost the same. This means that a system built for voice authentication can be repurposed into a system built for identification. This can be done without collecting any new data and hardly any modifications to the algorithm.
With so many concerns, why use voice recognition at all? There are several reasons. Without voice authentication, all our voice assistants on smartphones and in smart speakers, and voice interfaces for cars and robots are unsecured. So to have secure voice systems, we need it. And this is where things get messy. Speaker recognition systems are not perfect. They can fail by mistaking someone else for you, or by mistaking you for someone else. As a consequence of these mistakes, people can fall victim to crime, or be denied access to important services. New research shows that the rates at which voice biometrics make mistakes differ based on speakers' age, accent, nationality, and gender. If you value equality and inclusion, then this is a problem.
We have established FAIR-EVA to interrogate the impact of voice technologies. FAIR-EVA is an open-source project that helps developers, researchers, and consumers anticipate harms and build more inclusive voice systems. So if you care for a more trustworthy AI, join us.